Picture this. Deep beneath one of America's most iconic national parks, the ground is trembling, not just once, but in bursts, hundreds, sometimes thousands of times in a matter of weeks. These are the earthquake swarms of Yellowstone, and they've sparked fascination, fear, and plenty of wild theories. So, what's really going on beneath Yellowstone? And should we be worried about these mysterious shakes? Let's dive into the heart of Yellowstone National Park, a place famous for its geysers, hot springs, and jaw-dropping landscapes. But beneath all that beauty lies a geological beast, a massive supervolcano that has been shaping the region for millions of years. Yellowstone isn't just a park, it's a hot spot, a place where molten rock from deep within the earth is closer to the surface than usual. And those earthquake swarms? They're like the pulse of this restless giant, telling us it's still very much alive. First, let's clear up what an earthquake swarm actually is. Unlike a single big quake that might grab headlines, a swarm is a series of smaller earthquakes happening in a short period, often in the same area. Think of it like a popcorn machine. Instead of one big pop, you get a flurry of little pops, one after another. In Yellowstone, these swarms can involve hundreds or even thousands of quakes, most so small you wouldn't feel them unless you were standing right there with sensitive equipment. For example, in 2017, a swarm near Yellowstone's Hebgen Lake rattled off over 2,400 quakes in just a few months. That's a lot of popcorn! So, why does Yellowstone have these swarms? To understand that, we need to talk about what makes this place so special. Yellowstone sits on top of a massive volcanic hotspot, a plume of molten rock rising from deep in the Earth's mantle. This plume is like a blowtorch, heating the crust above it and creating a huge magma chamber, a reservoir of molten rock that powers Yellowstone's geysers and hot springs. But that magma doesn't just sit still. It moves, it shifts, and it puts stress on the rocks around it. When those rocks can't handle the pressure anymore, they slip, and that's when you get an earthquake, or in Yellowstone's case, a whole swarm of them. Here's where it gets interesting. Earthquake swarms in Yellowstone aren't usually caused by the magma itself moving upward, like you might imagine with a volcano about to erupt. Instead, they're often triggered by something else entirely: fluids. Deep underground, hot water, steam, and gases like carbon dioxide can get trapped in cracks and faults. As these fluids move or build pressure, they can lubricate the faults, making it easier for rocks to slip and cause quakes. It's like squirting soap into a stuck drawer. Suddenly, everything slides a lot easier. Scientists call this hydrothermal activity, and it's a big part of why Yellowstone is so seismically active. Now, let's address the elephant in the room: the supervolcano. Yellowstone's volcanic system is one of the largest in the world, and it's had some monster eruptions in the past. About 640,000 years ago, it blew its top in an eruption so massive it covered half of North America in ash. Naturally, when people hear about earthquake swarms, some start worrying that the supervolcano is waking up. Could these swarms be a sign that Yellowstone is about to erupt again? The short answer is, probably not. But let's unpack that. Scientists at the Yellowstone Volcano Observatory keep a close eye on these swarms using a network of seismometers, fancy instruments that detect even the tiniest ground movements. What they've found is that earthquake swarms are a normal part of Yellowstone's behavior. In fact, the park experiences about 2,500 to 2,500 quakes every year, and swarms make up a big chunk of that. Most of these quakes are tiny, with magnitudes below 2.0, meaning you'd need to be a seismometer to even notice them. Even the bigger swarms, like the one in 1985 that included over 3,000 quakes, didn't lead to an eruption. They're just Yellowstone doing its thing. To put it in perspective, think of Yellowstone like a sleeping dragon. The earthquake swarms are like its snores, sometimes loud, sometimes soft, but not a sign it's about to breathe fire. For an eruption to happen, scientists would expect to see other warning signs like major ground deformation, changes in gas emissions, or shifts in the park's geothermal features. These signals would likely build up over months or even years, not just pop up during a swarm. Right now, those signs aren't there, and the U.S. Geological Survey rates the chances of a major eruption as extremely low. But let's not dismiss these swarms entirely. They're still fascinating and important. For one, they give scientists a window into what's happening deep underground. By studying the patterns of these quakes, researchers can map out faults, track fluid movement, and even learn more about the magma chamber itself. For example, during the 2010 swarm, which included over 1,600 quakes, scientists noticed that the tremors were concentrated along a specific fault line, giving them clues about how the park's geology is shifting over time. Here, as a fun fact, Yellowstone-S earthquake swarms aren't just a modern phenomenon. Native American tribes in the region have long told stories of the ground shaking and the Earth's power, suggesting that these quakes have been part of the landscape for centuries, if not millennia. The Shoshone and Blackfeet, for instance, viewed the park's geothermal features as sacred, a sign of the Earth's spirit. In a way, modern science is just catching up to what indigenous peoples have known for generations. Yellowstone is alive, dynamic, and always changing. Now you might be wondering, if swarms are normal, why do they get so much attention? Part of it is human nature. We're drawn to the idea of a supervolcano, especially one that could theoretically cause global chaos. Pop culture doesn't help, with movies and TV shows hyping up the idea of Yellowstone blowing up and ending civilization. But there's another reason. Swarms can sometimes signal changes in the system. While most are harmless, scientists pay close attention to unusually large or prolonged swarms, just in case they hint at something bigger. For instance, in 2004, a swarm coincided with a period of ground uplift in the park, which got researchers excited. Not because an eruption was imminent, but because it showed the volcano system was active and evolving. Let's talk numbers for a second to ground this in reality. The largest earthquake in a typical Yellowstone swarm might hit a magnitude of 3 or 4, enough to feel if you read nearby, but not enough to cause damage. Compare that to the 1959 Hebgen Lake earthquake, a magnitude 7.3 monster just outside the park that caused landslides and killed 28 people. That wasn't a swarm, it was a single, massive quake, and it's a reminder that Yellowstone's biggest seismic risks aren't the swarms themselves but rare, larger earthquakes along nearby faults. So, should you cancel your Yellowstone vacation because of these swarms? Absolutely not. The park is one of the most monitored places on Earth, with scientists tracking every rumble, gas puff, and ground shift. If something serious were brewing, we'd have plenty of warning. Plus, visiting Yellowstone is a chance to witness geology in action. Those geysers, hot springs, and yes, even the occasional tremor, are all part of what makes the park so incredible. Imagine standing by Old Faithful, knowing that the same forces powering that geyser are causing those tiny quakes deep underground. It's like feeling the Earth's heartbeat. As we wrap up, let's zoom out for a moment. Yellowstone's earthquake swarms are more than just a geological curiosity. They are a reminder of how dynamic our planet is. Every tremor, every geyser, every hot spring is a clue to the incredible forces shaping the world beneath our feet. These swarms aren't a sign of doom. They're a sign of life, of a planet that's constantly moving, shifting, and remaking itself. The next time you hear about a swarm in Yellowstone, don't panic. Marvel at the fact that we were living on a world that is still writing its own story, one quake at a time. And who knows? Maybe that story has a few more surprises in store for us.